So now I think it's time for us to start this session. I'd like to welcome you all to the session on new traffic management tools and cooperation models. My name is Mikael Ivari and I work for the city of Gothenburg for the Urban Transport Administration. And when not moderating, I manage our innovation project portfolio within the fields of automation and digitalization. Before moving on to the presentations of this session, I would like to start with some housekeeping rules. And then to ask questions, I'd like you to go to the chat and then click also on session. And there you can post your questions to the presenters. Then we are not going to use polls in the conference system, so we can skip that one. But then if you like to view who's attending this session, then you can go to the people slide and then choose session. If you feel you need to maximize your screen, you can hide the chat or double click on the presentation or speaker. And then finally, after the session, we urge you to try the networking function and visit the exhibition area. So we can change slide, Niklas, please. So this is the agenda for today's sessions. We will have 4 presentations, and then at the end we will have a panel discussion. The presentations will be about 10 minutes, and we will leave 5 minutes for questions directly after each presentation. And please post your questions in the chat. Okay, with that, I'd like to introduce the first speaker of today's session, and that is Ms. Claudia Baumgartner. Claudia works as head of the Department for Research Projects at Verkehr, Mobilität, Zukunft Berlin, VMZ. She will give a presentation on the topic of strategic routing for cooperative mobility information and management services. Please, Claudia, the floor is yours.
Okay, thank you, Mikael, for your nice introduction. I share my screen and hopefully it works. You see my screen? Yes, you should. Yeah. So you see my screen. So this is what I'm going to talk about. It's about strategic routing for cooperative mobility information and management. And before doing that, I would just give you a very short idea about the company I'm working for. I work for VMZ, and VMZ is a company in Berlin that has a main focus on mobility information services. This is why we operate the Traffic Information Center in Berlin, and for 20 years and for 10 years we work on multimodal mobility information and management. What I'm going to describe you today is a concept of an ongoing project, a project we do for NVBW. NVBW is a public transport operator in Baden-Württemberg, and Baden-Württemberg is a federal state in the south of Germany, with Stuttgart being the capital of it. So what's the main aims of this project NVBW wants to have is three targets. First of all, with a cooperative mobility information and management, efficient and sustainable mobility should be achieved, but this is also should be based on new digital services that should be provided also to third parties. And not only these new services should not only be used by the cities or the traffic management centers or the public transport operators, but it should be open to third parties. So these are the three the 3 targets we are aiming for in this project. And what are the main components? Because we, VMZ, work on the digital innovation, and the key components of it is what has already been implemented, an open mobility platform and routing platform for the Public Transport Association in Baden-Württemberg. This is the key goal of NVBW. And of course, it's a platform that includes data from several providers and data that are both data for car traffic as well as public transport, as well as bike traffic. So this is what we do, and this has already been implemented, and you can see that in the website of NBWV. So this is mobility platforms, but how is it integrated and combined with traffic management? And this comes from here. We have also another key component, which is the City Mobility Manager. And this City Mobility Manager is somebody in the traffic management center that has access to the platform via a client that provides data on incidents and municipal strategies on how to affect traffic. This client helps to inform public about incidents, but what's also important is that this client helps to affect or to include strategies that helps affecting car traffic with regard according to city interests. And this is the City Mobility Manager that is also a key component of this strategic routing. And what's also important, as I already mentioned, is that the services that we are going to provide and to develop should be accessible, freely available for third parties. And this is why we also have this key component, information services. Okay, so that's the key component. And how is the overall concept of it? How does it work? First of all, the City Mobility Manager edits and integrates traffic incidences and strategies via this client that has been developed by a company that is called Prisma into the routing platform, especially in the car router. And this, since this platform is integrated, this routing platform is integrated in the overall mobility platform, then third parties have, via an open API, access to this routing strategies. So this is the overall concept of it. This is the concept. Now let's have a look on the basic facts, how we implemented it and where we implemented it. As I already said, we did it for NVBW, which is the Public Transport Association in Baden-Württemberg, and the first step was to implement it for the city of Stuttgart, with more than 650,000 inhabitants. And the perspective is to extend these services to the overall federal state of Baden-Württemberg, which means that then this services will help probably, or will 10 million people to have a good and city and city interested traffic. What we already did is that we implemented this intermodal mobility platform and the routing service based on OpenStreetMaps and INRIX travel times. And what was the main focus first was park and ride routings, but also routing strategies for redirection and alternatives routings. Still ongoing is, as I already said, this city mobility manager that is tested presently by NVBW. And what we also work on actually is how to give access to these services to third parties, and we do that via a widget. So let's get into the city mobility manager. What's clear is that the mobility manager uses the management information service they have in their control and management center, and they initiate the routing strategies. And there are currently 6 strategies that are being tested. One is alternative routing, which means that there is a route that avoids traffic in specific areas. The other is city traffic compatible routing that prefers routes between specific starts and destinations. Then we call it diversion routing, a redirection due to specific incidents. Then, of course, public management traffic and park and ride routing. And what's also important is a routing for environmental zones that take account of the alarm of PM10, because Stuttgart is also a city that is very much that has very often very high air pollution due to the topography of the city, and also due to the high number of commuting traffic. So this is the strategies the city mobility manager can include in the routing platform and in the multimodal platform. And the result of this, for example, for the strategy environmental zone, would be a clear route that goes that does not go into low emission zones, but that leads or routes the car driver and redirects it from the low emission zone. This is a result in diversion around these areas of low emission zones. So this is just one result of one strategy that has that gives you an example on how strategic routing for cooperative mobility information and management can look like, and what is the result. But what's also important is that we are currently working on providing the services to third parties, and we do this via internet widget, where the routing services based on these strategies can be easily and freely available for third parties, no matter whether they are public transport operators, no matter whether they are car traffic operators, or also third parties like museums or fairs or whatever. They can include this using this widget in their website. And this is how we make sure that there is an open and free access to this strategic routing based on the city mobility management and the multimodal platform. And this is how we do what's the overall aim, just to make mobility more efficient, to provide new services that are focused on the cities of on the perspectives of the cities, and they are open and easy and freely available for third parties. If you want to have further information about this, more technical information about this, I can share a paper with you. But in any case, that is on VMZ website. But then in any case, if you have questions, just contact me by email or contact my colleague Markus Jackenkroll from NVBW. Okay, that's it.
Thank you very much, Claudia, for your interesting presentation. And now for the audience, if you have any questions, please post them in the chat. We have one question posted right now, and that is from Antje Hamme. Would you like to phrase the question yourself, Antje? You're welcome to do that. Or if not, I can phrase it. The question is, are also transnational relations for public transportation, cars, etc., included in this project?
Yeah, we are right now. We are not transnational. We are just focused on Stuttgart, region Stuttgart, and federal state of Stuttgart. But of course, if this runs in a good way, and if there are good results, then of course we are going to have a more, we will extend it and get transnational too.
Thank you. Looking for more questions. Meanwhile, I have a question myself. You use a lot of data sets for providing your service. And then I was thinking, what non-existing or even non-available data sets would be on your wish list in order to refine or expand the service?
Yes, of course. I mean, the thing is that the data we get is data from providers that give access to their data. But in any case, I mean, this is always a thing that is related to all the multimodal mobility services, to have also, yeah, let's say, all the data or the data of all providers that are in a city or in a region, and of course it would be good if all the providers would provide their data.
Has that been a challenge in the project?
I think in this project not, but I know that this is a challenge in other projects too, because I mean, for example, car sharing providers, they want to very big car sharing providers, they want to have their contact to the clients by themselves and not by other people. And this is somehow also a topic that should be somehow changed. Yeah.
Yeah. So you run it,
but you cannot do that.
You come into conflict with existing business models.
Yes.
Right?
Yes. Of course.
Yes. Well then, I keep a look at the chat, and I see one more question from Helmut Augustin. Are your services actually integrated in the big navigation service providers, like Google Maps, for instance?
No, not yet. But this, Helmut, now you address really the very high challenge of this, yeah, because all the navigation services and the providers like Google Maps, they just are focused on the individual drivers, on optimizing the routes for individual drivers, but they do not have in the focus. They do not focus on the city interests, and this is the key challenges I think the cities have to address and have to get, that they have access or they can. That big navigation service providers are also sharing this information, because this is what the city wants to. And what I know from Stuttgart is that they are actually working on a project that is called, it's a national research project that is called City to Navigation, and this is here the focus on how can city information and city strategies be included into the services of big navigation services, but also in the routings in the services of the cars by themselves. So this is the challenge, and the cities now start to think about that and to find a solution for that. Because in the future this is going to be a main topic, because the private navigation service providers, they are very much used by the car drivers, of course.
Thank you. I think we have time for one more question, and we have a follow-up question from Antje. If there's a possibility to enlarge this project, especially in the trinational region of Basel or the Lac de Constance?
Antje, this would be very, very nice for me, because I'm coming from this area. And what I know, that we are actually also working on a project for Zurich, where we do this multimodal platform with routings, and so I think we can extend it to regions in Swiss and close to the Lake of Constance.
Okay, one final question from Reem Fadi. Does your routing take into account real-time incidents or accidents?
Yes, because it on a let's say reduced level, because we also use the real-time data of INRIX there for Stuttgart.
Well then, thank you very much, Claudia, for your presentation.
You're welcome.
And we will move on to the second speaker of today's session. And the second speaker of today's session is Patrick Hofman. He works as a traffic engineer at MAP Traffic Management in Utrecht, the Netherlands. And in his profession, he works with enhancing the impact of dynamic traffic management from a regional perspective by testing new innovative solutions. And he will give you a presentation on the topic of incident management in urban areas. So please, Patrick, the floor is yours.
Thank you, Mikael. Well, yes, indeed. My name is Patrick Hofman. I work for MAP Traffic Management. We are a small company based in Utrecht, in the Netherlands. And as it is in the name, traffic management, yeah, that's the field we're working on. Quite a broad field, from operational traffic management, such as incident management, which I'm going to talk about today, but also new features and new developments such as cooperative automated driving. But today, an operational view of the traffic management. We did a pilot in Amsterdam last year with incident management in the city of Amsterdam, and that's actually what I will use as a background for this presentation. Well, if you talk about incidents, most people refer to incidents and they see pictures like these. So big incidents on highways. Well, and we try to copy the processes to solve these incidents or to clean up the roads into a city. But well, yeah, an highway is definitely not the same as an urban area. So the incidents you see in cities are really different. Well, you can see, for example, accidents with cars, with vehicles, but also with damaged infrastructure, impact on safety. So the impact of an incident is really different than it is on bigger roads, on highways. You also see broken down vehicles. Well, in a city, there's often not much space to get off the road. So if a vehicle gets broken down, then it often will hinder the other traffic participants. And also you see more incidents of objects on the roads. This is a picture of a truck that has lost many potatoes. So the road is covered with potatoes in this case. But also you see lots of objects such as traffic signs or boxes or even chairs and things like that on city roads. And you see also some other incidents such as stopped vehicles to load or unload their cargo. Well, it's the same to broken down vehicles. There's not much space in cities, so if a vehicle stops on the road, then it will cause hindrance for sure for the other traffic participants. And then there are also roadworks. Well, not only roadworks, but also other works on buildings and things like that, but which are located closely to certain roads. That will also lead to changed traffic situations, for example, and also that situations can cause big disturbances for the other road participants. And finally, there's a category other disturbances. And during our pilot we came across strikes and protest actions in the city of Amsterdam. Yeah, well, that was also new for us. We didn't take that into account before the start of the pilot. So yeah, well, you see in the city there are many more or different kind of incidents than the incidents you often hear on the news or on the radio. But well, in short, all incidents that have an impact on and have a negative impact on traffic flow or traffic safety are considered in this case. So here you see a short overview of the incidents we considered in our pilot. Well, that's a first step, but you also want to solve those incidents as quickly as possible, or to manage the incidents happening on the road. So we used the city center of the city of Amsterdam to manage the entire process. So, for example, they had many cameras to monitor monitor traffic or monitor roads. But we also had we needed some people on the streets who really could go to the incidents to help the people involved getting as quickly as possible away from from the incident side. So we had two road inspectors driving in the city of Amsterdam. I will come back later to that. But well, here on the bottom of this slide, you see some examples of the more known road inspectors. At least in the Netherlands, mainly those cars are. You can see them quite often on the Dutch highways. So what did we do in Amsterdam? Well, the problem the city experienced was that well, there was so much congestion, and they wanted to reduce congestion, and the congestion was also causing CO2 emission problems. So the actual goal of this pilot, or at least of this pilot, was to reduce congestion and CO2 emission. And before we could start with the pilot, we actually didn't know that well what was actually going on in the city. So we tried to organize a process in which we could also identify the incidents happening already in the city, and to compare that at the end of the pilot with the incidents that happened during the pilot and the duration of solving the incidents. Well, as it turned out, I can already say that we didn't have that much information from before the pilot, so we didn't actually have many information about the incidents that already happened in the city. It was the information we had was more or less from people with, well, I think that what I noticed is that, and also from the city center of Amsterdam, they didn't keep track of all the incidents. They just tried to manage traffic after incidents already happened. So they kept track of the measurements they had taken, but not of the incidents themselves. And you can also say that should be a rule for the police. Well, the police department is and was very busy, and they had other priorities and still have. So that was another. Actually, that was also a kind of a goal of this project, to see how we can organize the process in such a way that also the police gets more time to do other important things. So firstly, we identified, after we actually didn't know how many incidents were going on in the city of Amsterdam, we identified the network we would like to have covered with this process. Well, based on different policy goals, we set up a network on which the road inspector, for example, would monitor the incidents. So that was our first step, and the next step was, of course, a very important one, to check the different roles and stakeholders needed for this incident management pilot. So first we checked, okay, we don't know how many incidents happen on the roads in Amsterdam, so we thought we should find a way how we can detect these incidents. Well, and after we have detected them, we should have someone who coordinates solving the incidents, and we should also have something in place when road users don't want to collaborate or cooperate. Then we should be able to call someone to help us out, and of course the incident handling itself. Well, for the detection, we used actually multiple stakeholders. It turns out that the city of Amsterdam has many departments who are often working outside. Well, we used those people as eyes on the road. So if they noticed an incident, or they came along an incident, then they could call the coordinator. In this case was the Traffic Management Center of Amsterdam, and the Traffic Management Center of Amsterdam then would coordinate solving the incident. And what was also new for detection of incidents was that we used some nice tooling. We used, for example, we built a tool to get an overview for the operators in the Traffic Management Center of incidents reported in Waze, a navigation system. And road users can report incidents themselves in Waze. So actually you have information from the road users available in the tool, and that tool we made available for the operators in the Traffic Management Center. And also the tool was used for logging, so we wanted to keep track of the incident handling. Well, for escalation, of course, we needed police, just for escalation reasons. And for incident handling, we used city road inspectors and tow companies, and also other emergency services and different city departments also here. For example, the department who took care of the infrastructure of green in case of fallen trees or broken branches, and enforcement. It's almost the same as the police, only with they are allowed to, the enforcement department are allowed to give fines, but they are not allowed to arrest people or something like that. So that was actually quite a nice distinction between the enforcement department and the police. And after that, we used for each stakeholder, we identified well the different roles, needs, requirements. So here for the city road inspector, we thought, okay, what kind of training does he need? What kind of vehicle? Which requirements does a vehicle needs to have? Well, a motorbike, of course, because city traffic is busy, and if you're driving a car, then you cannot pass the other traffic. Or well, yeah, you can stand in line at the end of a queue. But also clothing requirements, the operational hours, how many road inspectors will be, well, all that kinds of requirements of needs we took care of for each stakeholder. And also after that, when we did this process, then we made some nice operational processes for each stakeholder to solve what to do in which situation, and we translated that in operational instructions, which could be used by the people who were busy with the incident handling. Where they could look up the telephone numbers or the email addresses or the what to do in what situation and everything else. So they had actually quite a lot of information by hand. And well, after this, after all this work, we implemented the pilot itself. The pilot ran for 5 months. And well, of course, we also have some results of that. Well, at the beginning we thought it would be nice to compare a before situation and an after situation. Well, the before situation was really well. We didn't actually have any idea of what was going on, just some vague numbers. So that comparison, well, we couldn't make that one. So the results are really based on the findings of the pilot itself. And if you look at the pilot itself, and the duration of 5 months, we had 416 incidents, of which 70, and in my opinion, I think that's quite a lot, who had with a direct impact on traffic flow. So that were incidents causing some disturbances for other traffic participants. And the disturbance is not just one or two vehicles have to wait before a truck has left his loading and unloading location, but it was really based on the view or the opinion of the road inspector. We asked them to also to monitor the impact of certain incidents. and the instructions we gave them was that the queue must be longer than they could see. So we made it very practical for them. And then in this case, in the 70 incidents with impact on traffic flow, we managed to detect 75% of the incidents faster, meaning that or the road inspector or the tooling was the initial place where the incident was detected. So usually the incidents came through, for example, through the police or other companies. And then during this pilot, we increased the number of incidents with such a numbers just by monitoring the roads through the tooling and the road inspectors. And at the end, we also prepared a pilot for a survey for all stakeholders. And in that survey, we noticed that by implementing the incident management, there was a more complete view of the incidents in the entire city, or more insights in hotspots. So also for the traffic engineers, it was really worthwhile information we gained from this pilot. And well, the last point is that there was an increasement of the availability of time. What I mentioned before is that the police was really busy with other things, and in this case, this process saved them time to pick up other stuff. And what was also a good thing was that there was really a positive response from the citizens. So we got some feedback from road inspectors who said that drivers lowered their window and just said, "Oh, you're a good busy guy." And just by knowing that the city is busy with solving certain problems, I think the most catching part is that one of the road inspectors really said, "When can I start? When can I really start with being a road inspector for such a city?"
Patrick,
yeah.
Sorry for interrupting. I think we need to conclude.
Yeah,
time is running.
I just take a few words to just explain what is on the lessons learned. I think that's also worthwhile for other cities or other companies who wants to get busy with incident management. I think you don't have to implement such a big pilot or in such a big way, but you can keep it very small by looking very good into what is already available. So what kind of tooling do you already have? What kind of city department can help you in building up such a process? So I think this is really very worthwhile information to get started with incident management. Thanks. Sorry, Mikael. Now I'm really done.
Thank you very much, Patrick. No worries. Thank you for a very interesting presentation. Now, if you have any questions, please post them in the chat. We have time for one or maybe two questions, if you like. While waiting, I can ask you a question. I noticed this escalation principle, and then I was curious, is it common that road users don't want to cooperate?
Well, on the highways, it was a couple of times in the news the months before the pilot, with road users shouting out to road inspectors or other people working on the roads. Not only shouting out, but also going through barriers and things like that. So yes and no. It was quite a hot topic in the month before the pilot. But during the pilot, we didn't came across any incidents which needed that escalation for luckily.
yeah, that's good. Okay, then. Yeah, now I see a question here from Suzanne Holy. If the results were so successful, is Amsterdam going to continue using the tool? And has the road inspector been implemented?
Yeah, good question. Thanks, Suzanne. Yes and no. The pilot ended just before the COVID-19 came across the Netherlands. So yes, they really saw the incident management as added value to the traffic management processes in the city. So yes, they are willing to implement it definitely. So not the pilot, but the real implementation. So they actually want to continue, but in the city there are other priorities solving, at least which involves the COVID-19 crisis. So there has not yet been a signature of the mayor of the city yet. So when they get that, then they definitely will implement the incident management in Amsterdam. But they did well continue working with the tool, so they have a better view of the incidents in the city. So it's already a small step forward, I think. So it's just waiting until COVID-19 has maybe gone by to get also the next step in implementing the entire process.
Okay, thank you very much, Patrick. And thank you for your presentation. And then we will move on with the third speaker of today's session, and that is Dr. Giovanni Huisken. Giovanni has more than 20 years experience from ITS, working both as a consultant and as a project manager. He holds a position as Business Development Director at Map Traffic Management and is hired by Rijkswaterstaat to act as Deputy Project Manager for Socrates 2.0 and Activity Lead of Amsterdam Pilot Site. And Giovanni will give you a presentation on the topic of cooperative, proactive traffic management in the Metropolitan Region of Amsterdam. Please, Giovanni, the floor is yours.
Yeah, thanks, Michael. Well, apparently I'm not able to present myself, so I have some help. So I'll be shouting next a few times. So keep that in mind. Okay, so we were talking about cooperative proactive traffic management in the Metropolitan Region of Amsterdam, and this presentation is by Tiffany Flemings and myself, and I will be presenting. So next, please. Okay, so there's the content of this presentation. So first, one slide on problem descriptions, then one on the proposed solution, then the project setup, consortium and active partners, and the public-private partnership, which is all about the roadside and navigation in car, win-win-win, cooperation models, intermediaries. Actually, the win-win-win is out, I think. And finally, information flow of this use case in Amsterdam that we are focusing on, and some end user service. So next, please. So first, the problem description. So do bear in mind this was in early 2017. So pre-COVID situation, pre-corona. So the problem here was twofold. Well, more infrastructure demand than supply causes severe congestion in densely populated metropolitan region of Amsterdam. And the start of rerouting measures, which took place, which are started from the traffic management centers, the three we have in the metropolitan region, are usually reactive instead of proactive. So, and the current measures seem to be inadequate. And we tried to solve this by, well, not only be more proactive, but also to include other parties. So next slide, please. So the proposed solution is to be proactive. And how are we going to do this? Well, we have public and private partners, and we were trying to build a consortium to do a pilot on how to overcome these problems by building a common predicted operational picture with common goals, KPIs, and conditions for rerouting. So this is not only with public means, but also with private means. I'll come back to that later. And the orchestration of those cooperative proactive traffic management should be as established by using intermediary roles. And we have done this in the project that's called Socrates 2.0. And on the right-hand side, you can find the link towards our project, and you can learn more about it on that page. So please, next. So here we have the project set up. So we have a V model, going from high level, more strategic into more operational. So descending from framework design into piloting. We have 4 pilot cities within this Socrates 2.0 project, which is Amsterdam, Antwerp, Copenhagen, and Munich. And then going upwards again by evaluation and consolidation. And obviously we have a project management activity also. So we tendered this project at the CEFCOL on ITS, and yeah, luckily we were picked out and selected to move forward. So we did, and we started in the end of 2017, I think, and then did activity 2 in 2018 and activity 3 in 2019, and we are now at the stage of the activities 4, 5, 6, and 7, and also 8, obviously, because evaluation is in parallel with those other activities. Next slide, please. So who is executing this project? Well, quite a few names there. So we are the Rijkswaterstaat itself is involved, and obviously CEF by the European Commission, which is the co-financer. And we have the German BAST, B-Mobile, which is also shareholder of Flitsmeister, the app. We have brand makers, which have liaison to, for instance, Google. BMW, we have here, we have Map Traffic Management, Technology is in place, TomTom, the Flemish government, City of Copenhagen, and some road authorities in the Netherlands themselves, so which are gathered in the Praktijkproef Amsterdam, which is Practice Trial Amsterdam. We have the Municipality of Amsterdam, the Province of North Holland, NDW for National Data Warehouse Information, and Vervoersregio, which is the Transport Authority of Amsterdam. And yeah, those are the partners, and on the left-hand side you see the basic characteristics of those partners. So data providers, B-Mobile, BMW, etc. You can see it for yourself. Next slide, please. So what is the idea behind this Socrates 2.0? Well, it's a more or less public-private partnership. And what we want to do is to align measures and services and scenarios to take actively care of traffic management in this instance, the Metropolitan Region of Amsterdam. So we have traffic control centers at the public side, and we have back offices and data collection at the private side. And next. Coming together in roadside systems on the public side, on the public side, and smartphones and car navigation systems at the private side. Next, please. But that's not all, because we also needed some more or less neutral roles. So we developed a framework for cooperation. And if you go full blown, then you need, in our opinion, you need 4 roles there: the strategy table, network manager, the network monitor, and the assessor. I'll come back to those roles later. Next. And this all, okay, well, this all will go to the new and improved traffic management. So we have cooperation models. And they can be characterized by the way in which you work together. So if the first cooperation model is just to exchange data, inform each other of using an agreed protocol. Within Socrates 2.0 project, we have one service that is dedicated towards this, and that's called actual speed and lane advice. Next. Then you have a more increased cooperation. It's called the shared view. So you develop a common view of agreed information. And for this, you need one intermediary role, which is next. It's the network monitor. And one example of that service is environmental zones and road works. Those were also part of the Socrates project. And finally, we have the more coordinated approach, which is to coordinate end-user services. So there you have public end-user services and private end-user services. And one such a, oh, okay, this is interesting. One service is a smart route advice, which we will focus on during the remainder of this presentation. Next, please. Going along with those cooperation models, we also have identified intermediary roles. So that the exchange data cooperation model, we don't need an intermediary role. With the shared view, you need a network monitor role. And with the coordinated approach, next please, you have 3 additional roles. So the network monitor is also necessary, but you also need the strategy table, the network manager, and the assessor. So the strategy table is the place where the strategies of the public and the private companies are shared and distilled and fused. And then those strategies are more or less translated into KPIs. And in order to reach those KPIs, we have a network manager in place that uses data that's coming from the network monitor and distributes necessary measures across all the public and private corporations. And the assessor is more or less an evaluator on short-term notice and takes into account which party attributes to the common KPIs as mentioned. Next, please. So this is a rather complicated scheme. This is the architecture setup of the optimizing network traffic flow service in Amsterdam. So on the left-hand side, you have let's see, you have the public party as is. So you have collective goals, which are translated into strategies, and those are put in place by algorithms and measures on the roadside, influenced by the actual traffic state, obviously, and volumes, events, etc. And on the right-hand side in green, you have something similar, but then for the private parties. So they have private goals, obviously, and in the end, they also gather information. And based on the information they gather, they send out information towards the end users by in-car devices, which can be either telephone or a device itself mounted to the car itself. So into the middle we have the intermediary role, so the strategy table as mentioned, which is used for strategic goals and translate them into KPIs and all kinds of measures, and the measures are sent out by the network network manager, which uses data coming from the network monitor, and the assessor takes care of the data that is used to determine the impact of all those parties involved. Next, please. So here we have an overview of the information flow. So we get all kind of data from data sources. So we have induction loop data, which is coming from the national road authorities and also from NDW in the end. We have live traffic data from multiple sources. So for instance, in this case, we have the larger data providers such as HERE and TomTom and VMobile. And we have predicted traffic data from multiple sources. Those are fed into the network monitor, where data is fused for a common operational picture. And that data is forwarded to the network manager. There the problem state is detected based on the current traffic that is, well, that is coming from the network manager actually. And based on, maybe could go back, yeah, thanks. Based on that, automated service requests are sent out, and those automated service requests can be either avoid a certain route, please reroute according to this route, or find this and this parking lot. That last one is obviously not part of this use case, but there's some similarity with the presentation of Claudia, as you can imagine. Only we took a different approach that we used the data provider and service providers within the consortium, which gave us quite some exposure. So those service requests are also sent out to the traffic management centers. So we have a traffic management center from the National Road Authority, Rijkswaterstaat. We have a traffic management center from the province of North Holland and one of the municipality of Amsterdam. And they also send out measures, but then at the roadside. And the alignment between the measures that are sent out by the TMCs and the service providers is something which is quite new, because we have made some KPIs and strategic sessions on that by the strategy table. So the measures are aligned in that sense that they empower each other. In the end, all data is fed into the assessor who does the evaluation on short-term basis, and that might influence again the coming out of the strategy table once in a while. So this is the overall big picture. Next, please. And here you see one of the end user services, the one of Flitsmeister VMobile, and how it responds to the incoming service requests. So the network monitor sends out a service request, please avoid link X. And Flitsmeister then says, well, I'm going to identify all ongoing trips from A that will pass link X. And for those trips are fastest alternative routes B calculated, and if travel time from B is minus travel time from A is less than plus 15 minutes, this is a number that can be adjusted, obviously, to offer a reroute via B, showing different messages depending on the course of the redirection. And then the user either accepts or does not accept or rejects. And this is stuff we are now piloting, for instance, in Amsterdam, but also in other cities such as Antwerp. We have used the last few years to set up everything, and in Amsterdam since December from last year we were operational. Had some tweaking to do, some system optimizing, and then COVID came around, and well, that sort of changed the whole set of the project, which was, well, not so nice actually, but we learned some other things that we are going to share with you in more or less halfway next year. We have an end conference on this Socrates 2.0 project, and if you want to be invited, please make yourself known. And once again, I would like to show the link towards Socrates 2.org, where you can find more information, or you can contact me. And this is it for me, Michael.
Thank you very much, Giovanni. Thank you for a very interesting presentation. I think we have time for one question, and I picked the first one in the chat, and that is from Jan-Martin van den Berg. How scalable to other regions and countries is this coordinated approach?
Well, since we have implemented this in multiple cities, for instance, this is going on the optimizing network traffic flow. We have implemented this in Antwerp and Copenhagen, so we should have some information about how scalable this is. But depending on which cooperation model you choose, this is scalable for, I would say, any city, as long as you have a traffic management center and service providers, and well, service providers are acting within Europe, at least, if not bigger. Excuse me. So I think this scheme, as it is scalable. The impact it will have depends on the richness of measures you have at hand, and also on the density of the service providers in the traffic flow.
Well, thank you very much for your presentation and your answer.
Okay.
Now we will move on to the last speaker of today's session, and that is Casper van Gheluwe. Casper works as a PhD researcher at the research group Intelligent Systems Engineering at Ghent University, and he focuses on the boundaries between governance, mobility data management, and computer science. And he's also the founder of tech startup Maplix. He's going to give you a presentation of TMaaS, and this is a cloud-based, vendor-neutral, multimodal traffic management tool. Please, Casper, the floor is yours.
Thank you, Mikael. So welcome everyone to this presentation about the TMaaS project, Traffic Management as a Service. This will be an interactive presentation. We will ask some questions from the audience. So if you want to follow along, I invite you to go to www.menti.com and use the code 2538389 to participate in the presentation. I believe the link is also available pinned in the chat for in case you don't have it. So TMaaS itself is actually a personalized or personalizable, vendor-neutral, multimodal, real-time traffic management solution for both citizens and traffic operators. And it was developed by these partners, so the City of Ghent, TomTom, Waylay, B-Mobile, Ghent University, the European Passengers Federation, KU Leuven, and finally also the Staatsrecht. Maybe to warm up, how familiar are you already with these innovative solutions in traffic management? So how familiar are you already with real-time mobility dashboards, with open transportation data, with city and private partner corporations, and also with data marketplaces? I can see already that some votes are coming in. I will give the audience some time to answer, of course. It looks already like we have a quite knowledgeable audience here, which is maybe not unexpected, of course. Okay. Okay, yeah. It looks like, yeah, especially open transportation data is already many people are already quite familiar with this. But the cooperations with cities and private partners and the real-time mobility dashboards, and especially the data marketplaces, is something that you are not so familiar with. And actually, most of these, actually all of these, are in some way included in the TMaaS solutions, which I will discuss now. So if we look at what TMaaS tries to do, it all starts from a couple of types of data. We have, like in the previous presentations, there are a lot of traffic incident data. There is weather information. There is information about bicycles. This includes bicycle parking real time. It includes bicycle sharing availability, and so on. There is information about pedestrians. We have counts of how busy it is in certain areas and how many pedestrians pass by certain stores. But of course, yeah, it's also important to have information about public transport, real-time schedules, locations of stations, ways that you can switch from one type of public transport to another. And there's also, of course, a lot of motorized vehicle data sources, but also car sharing and so on. And basically in TMaaS, we kind of try to combine all of these very heterogeneous data into one big system, where this data can be aggregated, analyzed, and then displayed on the mobility dashboards. There is also a control dashboard where the operators can decide which data is available to whom. And there is also some data that is proprietary or that perhaps should not be easily shared. And in this case, this data is then sent to a vendor-neutral person who will aggregate and anonymize this data so that companies such as TomTom or BeMobile are more willing to share their proprietary data on traffic incidents with the general public. Finally, when all this data has been aggregated and analyzed and is anonymous, it is made available both to the mobility managers who receive a TMaaS real-time dashboard and to the citizens who can use the dashboard also to view the current traffic situation. And it is also made available via public APIs to other service providers who maybe want to use all this rich information about traffic in certain cities. Now, we developed these TMaaS solutions for 4 cities. Firstly, it was the city of Ghent, who is also the project lead partner. There we developed the platform link.ghent. And then there was an open call placed for replicator cities, so cities who were interested in redoing or in reusing the TMaaS platforms. And 3 cities were decided. We have Southwark, a borough in the city of London in the United Kingdom. We have Antwerp, another city in Belgium, and Durand, which is a large city actually in Ecuador in South America. And we will look at how the TMaaS solutions look. I will do a demonstration. So for the city of Ghent, this is the link.ghent platform. You can see I'm currently on the pedestrian and bike viewport, where we can view the bicycle network in and around Ghent. We can view the bicycle counters. We can click on these to get up-to-date charts that show how many bicycles were counted at this counting point, what speed they were. The map itself is also interactive. You can click and then you get some information about the layer that you are looking at. There are a lot of available layers for all kinds of transport modes. And even some that are very interesting specifically for traffic managers, like the situation of traffic lights or the current signs, variable message signs in and around the city. And then there is also a couple, well, actually quite a lot of widgets that display the historical evolution of certain things, such as the occupancy of parking lots. Indeed, this is part where the cooperation with several private companies comes into play, because many of these parking garages are not operated by the city itself, but by private companies in and around Ghent. And so they cooperate by sharing their data. Some of them have certain licensing requirements. For example, we are not allowed to show the exact numbers, but only estimations of the actual occupancy. There are multiple viewports that are pre-developed by the traffic operators. So pedestrian and bike, public transport, current road info. For example, this will show kind of the traffic situation, traffic incidents. So this is a traffic jam currently very close to my home. You can see a listing of these. You can draw categories and so on and so on. You can get a view of the car traffic currently in Ghent. So all the major roads in and around Ghent are displayed here. Which roads are displayed are actually configurable by the traffic operators. So they can decide which of these roads should be tracked and also available for long-term analysis on the occupancy. And actually, there's also the parking view where we have all these car parkings and also electric vehicle charging availability and so on, all in real time, and for some of them also. Okay, I'm a bit lost. Yes. So for Ghent. Then for Sodark, we also have basically replicated this based on the data sources that are available to them. So for them, we got data from the Transport for London agency, but also from the borough of Sodark itself. And we have, for example, also again their bicycle network. We have traffic incidents, roadworks, car traffic, electric vehicle charging, although in this case not real time. And also vehicle counts on a couple of important crossroads in and around Sodark. And again, if you click these, then you get an updated view down here on the number of cars or the number of bicycles that were counted at that crossroads, depending on the hour as a sum. So the traffic operators there, they really want to go for a shift to real-time traffic management. And for this, they wanted some tools to keep track of the traffic density in and around Sodark. And our solution is, of course, again, the real-time mobility dashboard, similar to the one that was provided for the city of Ghent. Antwerp, there we had a bit of a different approach. In Antwerp, they actually already have access to a multimodal dashboard, which is called Slim naar Antwerpen. But it doesn't yet include any routing suggestions, which is also something that TMaaS can provide. Basically, every citizen who subscribes to the platform can enter their preferences and also their common routes that they take, for example, from home to work or to bring their children to their school and so on. And they can decide, okay, I can do this by bus, I can do this by tram, I can do it by car, I do it always on foot and so on. And based on all these preferences and all the routes that they enter, actually the TMaaS platform can generate very good notifications in case there is a disturbance on that route. And that can be very broad. If it's car focused, yeah, okay, then it's typically incidents that happen or traffic jams that may mean that you are late to your appointment. But it can also be related to weather situations, for example. If you typically take a bike, but it is going to snow, for example, it will suggest alternatives. For example, it will tell you, okay, maybe today you can try to use the bus to go to your destination instead of biking. It can work in all these systems. For this, I can also show. This is the interface for this. So we developed this interface where the citizens can enter their routes. Let's say I live in Schoten, for example, and I often travel to the city center of Antwerp. So here, probably it's not accessible by car. No, okay. Let me just reload just to make sure that. Okay, that's unfortunate. Yeah, my session was. I had this window open for the whole presentation, and then my session was no longer active. Okay, we will do it again.
Casper, I think we are running a bit late. So,
okay,
yeah, I think.
Okay, I will just continue. Okay, no problem. So we have these multimodal route suggestions, and basically our solution was to integrate the TMaaS triggers and notifications module. In Duran, the city of Duran, there actually the traffic management want to optimize the bus services, which are currently not very well managed. But we provided for them a public transport fleet viewer so that the buses that are deployed inside the city can be tracked by the traffic managers, both in real time so that they know where the buses currently are and if they are maybe stuck in traffic and so on. But also historically, this data is saved and then it can be used for analysis later. for example, to see where buses maybe get stuck often, maybe the routes need to be changed to avoid certain busy intersections, and so on. I don't have time to demonstrate this, but we can continue. So finally, to conclude, yeah, I am really interested to hear from you which of these city cases that I presented is most interesting to you. Okay, we have a early preference for Antwerp, but it's still early. Okay, very interesting. So it seems from the response so far that Antwerp, so the real-time notifications and also the trigger system are very important, and also the Ghent case. Of course, this is the most complete case because it was the project lead. But yeah, also Stadart. Indeed, the Durand case, yeah, I was not able to demonstrate it, but can also be interesting. And finally, yeah, if you're interested in TMaaS, actually there is a survey ongoing right now that questions the adoption potential of TMaaS. Basically, we want to ask your opinion on what the market potential is for all of these solutions that we developed to see what is feasible. You can participate in the survey. I warmly ask you to participate via the link that is probably not yet in chat, but I'm sure either me or one of my colleagues will post it there very soon. Thank you. That's the end of my presentation.
Thank you very much, Casper, for an interesting presentation. An interactive presentation was very good. I will only allow one question because we're running late, and we have a question posted here in the chat. That is, does TMaaS deliver both a customer-facing and authority-facing dashboard?
Yes, so indeed, the citizens get a dashboard view, which is personalized to their mobility profile. So when a citizen registers, they get to answer a couple of questions about how they perceive mobility and then how they use mobility services. And based on that, they actually get access to their own personalized dashboard views, which they can then customize. And at the same time, yeah, there is the authority-facing dashboards, which is much more focused on the traffic management. And there you get certain tools that the citizens perhaps do not get. It's up to the operators to see what the citizens can see and what they cannot see.
Thank you, Casper.
No problem.
Then I would like to wrap up this session with a final panel discussion on the topic of how to take advantage of new traffic management tools for the cities from a city perspective. And then I would like to invite all the presenters to turn on their cameras. And also for the audience, if you have questions on the topic on how to take advantage of new traffic management tools, please post them in the chat. I will start this session, this final topic, by asking you, Claudia, what do you think are the key challenges from a city perspective to take advantage of new traffic management tools?
Yeah, I think it was already asked by Helmut. This how has a city has an objective to affect car traffic on the perspective of the city interests, and what actually do this is private navigation providers. And to get access to their solutions, this, I think, is a really key challenge the city has to address somehow in order to really have, to really be able to affect the driving of individual car drivers with their routing strategies and their information. This is my idea about that.
Thank you, Claudia. I don't see Patrick. Patrick is here. Hi, Patrick. I'd like to hear your view as well on this question. The key challenges.
Yeah, can you repeat your question, please? I will have also some issues logging in.
Yes. What are the key challenges from a city perspective in taking advantage of these new traffic management tools? In your opinion, what are the key challenges from a city perspective?
I think the key challenges are mainly, I saw it also in the chat passing by. I think one of the main challenges is organization. So what I mean with that is that I think there are many possibilities to implement traffic management solutions or tools, but I think there are also many departments of cities already involved in traffic management tooling or other things. And I think when bringing all together all those different departments or all those different people will already help in setting a first step towards new tools, innovative solutions, and more new good stuff. So I think the key challenge is to organize themselves, or well, of course there are many companies who can support cities by doing that, and get a better view of necessary steps to be taken.
Yeah. So organization. Thank you, Patrick. Then I'm turning to you, Giovanni. What are the strategic choices for a city looking to take advantage of traffic management, in your opinion?
Yeah. Okay. Well, that really depends on the policies that cities have, right? So if your policy is to have a green city, then your traffic management measures will be different than if you are aiming for full-blown economic drive. Also, safety might be a key issue, and usually what cities do, at least that's in my experience, is they have a sort of distributed vision, or a vision that is made up by several road authorities. So, for instance, for the north of Holland, there is the province of North Holland, several municipalities and the Rijkswaterstaat. They have one integrated vision for that part of the country, and that vision is then translated into strategies. And one of the strategies has to do with traffic management. But you could easily also include traffic management as a service, as described by Casper. And also, if you want to have traffic away from schools, for instance, that is a more tactical or operational measure that will in the end finally land into traffic management. And you can make you can start chatting about that with service providers in order to keep that traffic away there. Yeah. So I think it mainly depends on the policy that you want to implement, and the amount of space and money and time you have available to go to those policies.
Yeah, so start with the policy perspective. Thank you, Giovanni. I'm looking at the chat. I don't see any questions from the audience. So my final question will go to you, Casper, since we're soon to end this session. Which cooperation models do you think are available as you see it? Yeah.
Well, I touched upon it briefly during my presentation. So within TMaaS, we really use the vendor-neutral approach and the neutral third party. Basically, companies can provide their data to TMaaS, and if they consider their data to be proprietary, or if they do not want to share all the details because of competitive reasons, they can choose to have a neutral third party, for example, a research institution. In the case of TMaaS, it was actually Ghent University. to make this data anonymous, and then provide a new data feed that is anonymized, and therefore it allows for much more cooperation between competitors, even if they provide the same kinds of data. And this way, cities can get access to a lot more data on traffic management than they would normally be able to get without these kinds of arrangements, I think.
Thank you, Casper.
Yeah, that's also the experience that we got in Socrates. We have several data providers like TomTom here and VMobile. And if you have a more or less neutral, which we call intermediary organizations, in this case the National Data Warehouse was the neutral organization that did the data acceptance and fusion and distribution. So yeah, I agree with Casper, a neutral organization or institution, or what you want to call, with the accompanying platform. That's one way to go. At least that's has proven itself.
Yeah, so summarizing then, you should start with your policies, include a neutral intermediator, and also make sure that you connect internally also in your organization, and try to reach out also, as Claudia mentioned, the challenge with the existing traffic information system, and try to make them work together to support the policies and the objectives you want to achieve. So this session is now coming to an end. Thank you. I want to say a big thank you to all you presenters, panelists, for your inspiring presentations. And I would also like to thank you, the audience, for attending this session. And that's it. Thank you very much. Goodbye.
Goodbye. Thank you.
Bye.